Hello friends, I'm back with another video and this time it is Monolith versus Microservices. As you can see in the image, one big system we call it as Monolith, and how we actually divide that system into multiple small pieces is what is Microservices, which is shown on the right side. This is a concept which is very important because almost all applications which are developed nowadays are built on microservices, and I would not say that entirely 100% is all microservices everywhere. There are monolith systems in this world, but almost more than 90% of the applications across the world are working on microservices. So we should know what is the concept of microservices and why microservices is a better option than monolith. So let's dive in and understand these concepts. Okay, so in the previous videos we saw how actually any application, whenever somebody is accessing that application, one moment, whenever anyone is accessing any application, let's say it's a mobile app. When they access that application, you go via the internet, you try to connect to a data center, you connect to a web layer, then you connect to a app layer, then you connect to a database layer. Correct. Now this, we were always calling this as front end, and this entire portion is called as backend. In this backend, this application layer is the most important layer, as your business logic stays here. Okay, your processing, whatever happens with your instructions which are coming from here, they are actually processed over here. Okay, now this application layer can be in the form of two ways: either it can be a monolith or it can be a microservices architecture. Okay, so basically when I say monolith versus microservices, I am actually talking about the application layer, how your application is designed, whether it's a monolith application or whether it's a microservice application. So let me just zoom in only at the application layer. To make it very simple, you can imagine that if you're operating on a monolith application, you may have basically a VM or a server on which your application is running. Simple. Okay, if I say microservice based architecture, then you may have a VM or a server, but your application will be broken down into small services. Maybe I'll say app 1, app 2, for the sake of simplicity, app 3, app 4, and all these small services are called as containers. Okay, so this is a very simple uh, you know simple differentiation between a monolith and a microservice. Okay, microservices are basically containers, and monolith is a single VM. Maybe if I give you some more background on this. Okay, when you have, let's say, okay, let's say you are setting up, right from the infrastructure, you're setting up an application. Okay, so how monolith happens, right? Or maybe not. I'll not get into monolith right now. I'll get into the advent of microservices, how it happened. Let's see that how microservices are architected, because understanding monolith is very easy. You know that there is a VM, there is a server, you install an operating system, you install some application server like WebLogic or WebSphere, and then you run your application, right? And just write WebLogic. Okay, this is monolith. But the difficult part is to understand what are microservices, how these are set up. So let's say I'm just setting up the entire application right from the infra. So what you will have, you will have a bare metal server. Okay, on that bare metal server you may install, maybe going back to, let's say, 20 years back, you had a bare metal server, physical server. Okay, physical server, you installed the operating system on top of it, then you installed some application server. Application server means WebLogic, WebSphere, etc., .NET framework, etc. And then on that application server, you have your application or your code running, right? This was the simple architecture. Then we moved on from this architecture to another architecture where you have your bare metal. Then you introduce something called as hypervisor, like VMware or Hyper-V. Then you had VMs, okay, in which the operating system automatically came, RHEL or Windows. Then you had your app server and then your application code. Okay, this is also very much used nowadays, this architecture. But if I want to break this and explain you how containers or microservices are deployed, you will again have a bare metal server. Then instead of a hypervisor, uh, you may have a layer which will be called as Kubernetes. So you can imagine this is also a kind of a hypervisor only. I mean, this is very hypothetical, by the way, just to give you an analogy. Okay, hypervisor helps you build VMs. Same way, Kubernetes helps you manage containers. Okay, so Kubernetes, then you will have your containers. Now imagine these containers have their own OS related files, plus they also borrow the kernel files from your host OS. Okay, just keep that in mind. So containers, then you will have some embedded app server and then your application code. So this app server which is there, okay, this is embedded into the container image. Okay, so this is the difference basically between a containerized deployment and a VM based or a old style deployment. So you will have, for a VM based bare metal hypervisor like ESX or Hyper-V or VMware, then you will have your VMs deployed, then app server like your Tomcat or maybe WebLogic, etc., then your application code. In the world of containers and microservices, you will have your bare metal, you will have some host OS also on top of it, then you will have your Kubernetes layer, then on top of that Kubernetes layer you will have containers which are your nothing but microservices. Then you will have your embedded application servers like Tomcat, Netty, etc., and then your application code. So this is the basic deployment difference between monolith and microservices. Okay, now I'll give you some other analogies as well, because since I started with that image in the beginning, so what I will do, I will give you a simple example also to relate. uh, Imagine that you are in a restaurant, right? You are in a big restaurant and there are tables, okay, and you have a big kitchen. Now this kitchen may serve maybe burgers, then you have pizza, then you have Mughlai, then you have coffee, right? Now this restaurant, okay, can manage all these food items to be served to these tables, okay, but it has a limitation. Okay, let's say for example this is a a kind of a Indian restaurant, okay, and it cannot serve you continental food, or it cannot serve you a specific specialty like South Indian. Okay, it is only serving you North Indian food. Okay, so there are limitations. That means, first of all, there is a limit to the kind of food which can be served. Secondly, if there are too many customers which are flowing or which are coming into the restaurant, okay, what can happen is that to manage all these food items and provide uh, you know um, provide at the fastest speed will be difficult. So where I'm trying to allude towards is that if this, instead of having this big restaurant and this one big kitchen, if you have a concept of food court. I hope everybody has gone to a food court. Nowadays, in every mall, there is a food court. So you will have a separate small outlet for North Indian. You will have a separate outlet for coffee. It can be Starbucks. You will have a separate outlet for, let's say, KFC. Then you will have McDonald's. You will have uh, maybe some South Indian restaurant, uh, like, if I remember one, Thambi, okay, and many more. And when you see this architecture, see, if this big restaurant is there, somehow this restaurant owner decides to close this restaurant, then everything which is there inside the kitchen will stop serving. But then in a food court concept, if the coffee shop is not available, the coffee outlet is not available, still other outlets are still running, right? Okay, and maybe another example which I can give you, that if lots of customers go towards KFC, only the KFC guy may have to increase the resources over here, maybe the staff or the material, correct, without impacting the other outlets, right? So this food court example against a restaurant may help you understand that the restaurant is something like a monolith, and food court is something like a microservice, where all these are containers or microservices. Got it? Okay, so this analogy I wanted to give you guys. Let me actually get into a IT example. Okay, so okay, so now let's say if I want to build an application on Monolith. So in Monolith, when we build an application, ideally you will get one file. Your code will be compiled into one file that is normally called as a jar or a war, right? Java archive file or web archive file, right? So in this one file, you can imagine, if you're building a banking application, you will have your account module, your payments module, your loan module, your um, maybe notification module, right? There are so many modules which are going into a single file, squeezed into a single file, single jar file, right? Now imagine the challenges which you will face if you have this, because you have such modules, let's say 50 such modules, you have different modules, and you are building and creating a single jar file. Now every developer who's working, let's say some developer is working on accounts, some developer is working on payments, some on loans, some on notification. Now everybody cannot simultaneously work on this single file, and everybody cannot simultaneously wait for his code to compile and then run, because it's a single file. If the account guy makes some change that can impact payments also, loans also, notification also, or basically maybe the payment guy wants to do some development, but he has to wait for the account guy to complete, right? So these are the some challenges which makes Monolith a bad architecture for a deployment for a large application. So just imagine if the same architecture would have been where you know account is having a separate file. In this case it will not be a file, because if you're talking about microservices or containers, this will be a sorry this will be a Docker image. Okay, so you can imagine account, then same payments, separate file, loan module, separate file, notification, separate file, right? So all these developers can actually individually work on so many files. Okay, and there is no dependency on each other. They can communicate, and these services can in return call when they are deployed to each other. That should not be a problem. But the from a development perspective, if you see in a microservices architecture, okay, you have everybody working on their own individual files or individual images which they will build. Ultimately it's a Docker image which is built. So basically, whenever they are doing development, they first build a jar, and that jar is actually converted into a Docker image. Okay, so this is how this is the difference between Monolith and microservices. And furthermore, just to give you some advantages of uh, microservices, one already I gave you, right? Independent development. Okay, that means all these developers can independently develop their code. Then once these microservices are deployed, that means imagine that these are all these are all running, let's say these are all running in an environment and serving customers, then you can independently scale them. For example, payments load is much more on the services than loan and notifications. So you don't need to actually scale or increase the number of pods or containers for notifications. That means you don't need to increase these pods. In fact, only the one where there is a problem or there is load payment services, you can keep on scaling horizontally and creating more microservices for that specific payment microservice. But the same thing you cannot do it over here. Is if only payments is having a surge, or payments is having more demand of customers connecting to this payment service, then you have to make the replicas of this whole VM, you know horizontally, which will again have loan, notification, account, and everything, and all the 50 modules which you don't need, right? So that means independently you can scale specific services. Then you have something called as fault isolation. So when I say fault isolation, means let's say if your notification service goes down, that does not impact your other modules, right? Because your other modules microservices are running independently of notification service. Your transactions will still go through, only notifications will not happen for, let's say, 10-15 minutes to the customers. So that is the advantage of microservices. It gives you fault isolation. Then you have technical flexibility. By the way, this is also a very big advantage. When I say technical flexibility, it means that not necessary that all these microservices will be built on a same uh, technology. Let's say Spring Boot, right? I have the flexibility to create this container in Spring Boot, maybe another container in Python, maybe another container in .NET, right? That flexibility is not there over here because it's a single technology, single jar file or a single war file, right? I cannot have that. So that's the reason you don't have this technical flexibility, I should say. Okay, and of course you have faster releases. Releases means when you go to production, since your development is faster and you are actually releasing independent modules, right? You're not releasing everything at one go. So your releases are much more faster. So previously, I mean, it was always like releases used to happen quarterly in times of Monolith, but now those releases can happen weekly also, because you are independently deploying microservices modules or packages, or changes in microservices or modules, which can happen weekly also. So these were the few advantages of microservices and the difference between monolith and microservices, which I wanted to give you a view about. I hope this video was informative, and if you find it uh, clear and comprehensible, and you're able to understand the difference between microservices and monolith properly, then do give me a like and subscribe my channel. Thank you. Thanks a lot for watching. Thank you. Bye bye.